Let's start. Good morning. My name is Olga Boychak. I am a lecturer in digital cultures at the University of Sydney. And it is a great pleasure today to have Dr. Tim Graham from the Queensland University of Technology, who's a senior lecturer at the Digital Media Research Center. Before we begin, I would like to acknowledge the land of the Gadigal people of the Eora Nation, in whose lands the University of Sydney stands, and pay my respects to their elders past, present, and emerging, and extend this respect to any participant who is with us today on campus or joining us remotely. Without further ado, I would like to turn it to Tim. Oh,
yeah, thank you, Olga and Jen and everyone for arranging this session today. So basically, we've got 2 hours of glory. I'm going to be, so the background to this workshop, well, as you can see, you can kind of get a taste for what's happening already. We're going to be doing quite a bit of coding. But this workshop is essentially kind of like a 2-hour deep dive into some software that I've developed as part of my Australian Research Council DECRA project. So I'm on a 3-year research grant, which is amazing, but kind of daunting as well, because I'm building tools to detect and combat coordinated inauthentic behavior on social media. So I'm kind of building software tools that are able to take as input social media data and generate like networks that you can analyze qualitatively or analyze quantitatively to look at all sorts of different forms of like coordinated activity that turn up online. So, I mean, on the one hand, please forgive me because this workshop is like the bleeding edge of this DECRA project. So what I've tried to do for these 2 hours is to make it as simple as possible for like everyone, regardless of like what hardware you're running it or anything, or how much coding experience you have, ranging from like nothing or even like I'm traumatized by coding and don't want to do it, right through to like you're a gun programmer. So hopefully like this caters to everyone, and I'm trying to thread the needle in this workshop so that, you know, everyone can kind of get something out of it, depending on what you're up for. So the first thing to give a bit of background before we jump in, I've got on the screen here a Google Colab notebook. So basically what this is, it's kind of like, I don't know if anyone's familiar with Google Docs, but it's kind of like the equivalent of Google Docs, but for Python coding. So what we're going to be doing is running through this notebook, essentially. It has all the code that you need to generate the networks and to do analysis. We're going to walk through like all the different aspects of it. But you will need, I think you do need like a Google account. So if you don't have one, it's probably okay. You can follow along just fine. But if you do have one, it means that you can more or less, like after the workshop, you can start like generating your own networks and saving them to disk and, you know, kind of doing whatever it is that you want to do, like using this kind of software. So I just want to give like a quick bit of background here on what it is that we're actually doing. Again, I mentioned that this is part of the DECRA project, and I'm very fortunate to have Rio here, who I guess everyone knows about by now. And Rio is doing his PhD on an even more advanced topic than this. It's kind of related to this. So Rio's looking at multimodal, so images, you know, potentially videos, text, all sorts of different kinds of media, multimodal coordination in online networks. So he's studying, for example, you know, I don't want to kind of summarize your research too much, but I think it's like it's a great kind of entry point. The ability to study like meme warfare, for example, in online networks. The ability to look at when people are all sharing the same kinds of images at the same time, whether that's for activism purposes, you know, whether it's relating to like the Ukraine war at the moment, regardless of what it might be. And so this is more focused on sort of traditional coordinated behavior on social media. This is kind of like the flagship of the DECRA project. And what you can see on the screen here is actually a real, this is an award-winning image, believe it or not. I'm terrible at network visualization, but somehow or another this, you know, I was encouraged to like put this visualization into a competition, and it came in second place. But you can take this seed of an idea, this way to present social realities as networks, and you can really scale them up massively using social media data. And this enables you to take in data from social media. And I think Twitter is probably like the foremost example. to get Twitter data, and there's a lot of stuff that happens on Twitter. But in principle, this toolkit would let you import any kind of data with a little bit of extra work, and we'll get to that if we get time, and be able to generate networks like this. The networks show you connections between accounts based on the form of behavior that you're interested in. So this network in particular, it shows like 9 in the first US presidential debate in 2016. So debate night 2016 is the hashtag, and a bunch of other related hashtags that we used. We collected a data set, it's like ancient history, it's 5 years ago, of, I think it was 6.5 million tweets that were sent during that 90 minutes. And what we wanted to look at was coordinated retweet behavior. And what do I mean by coordinated? What it means is that accounts are connected together if they both retweeted the exact same tweet. For this work, and this is one of the most difficult papers I've been working on, and it still isn't published yet, even though I've done other work on the 2016 US presidential election and the presidential debates. We still can't figure out how to write the results up about this because it's kind of controversial, and we still don't know how to interpret them. But what we found was that we wanted to map accounts that were retweeting the same tweet within 1 second of each other, often hundreds of times over and over again. And like 1 second, like we can do it if we tried. Even if we all got our Twitter accounts out, if you're on Twitter, and we said, okay, as fast as you can, let's all try and retweet the same stuff. 1 second is pretty hard to do. And so we suspect that the accounts in this network are probably, they're probably used like machines to control them, or at least to some extent control them. And here's the thing, the blue ones are still active today. So you can see these clusters. I don't know what the easiest way to sort of highlight here is, but you can see that there's these clusters. These balls contain like hundreds and sometimes thousands of accounts that were all retweeting the same stuff within 1 second of each other over and over and over again during this debate. And this is where things get a little bit spooky. So you've got these, blue clusters, and the blue nodes are still active today. They're still on Twitter. If you go look at them, they're probably still there. The red nodes have been suspended by Twitter for breaking the platform rules, and I suspect that it's because of coordinated inauthentic behavior. But the really scary ones, in my opinion, so you can see there's clusters where there's lots of blue ones and lots of red ones together. These, to me, are the most interesting and most difficult to analyze and discuss, because a lot of them are like genuine Black Lives Matter activists, basically. And the issues that they're concerned about are real. They probably are authentic, real people. But they've been infiltrated by that have been suspended for trying to co-opt these communities and get them to sort of spread their preferred narratives. They basically were trying to spread the idea that Hillary Clinton is not a worthy candidate, that Bernie Sanders, who was the other for the Democrat Party, would have been a better choice. Don't go and vote, basically. And anyway, I'm kind of getting into the weeds a little bit here, but you get a sense of what this toolkit can do. And so, this was work. I published a whole bunch of and a coordination network tool, all sorts of stuff. So you don't have to look at bots and trolls, inauthentic behavior. You can look at activism, and networks and things like that. You'd be surprised like how tight these clusters are when people really care about like the latest episode of The Boys or something like that. They sort of turn up. Yeah, just as kind of a quick bit of background, again, to sort of motivate like the use of this toolkit. Those of you who know me, I'm very active, I guess, on Twitter. And I use Twitter as a sort of public engagement platform where I try to skip the slowness of like the peer review method and just like do analysis, publish the code, publish the IDs to the data sets, and then just like journalists, talk to journalists and advocate, for various different issues. And here's an example from a few months ago where like a colleague, Mark Owen Jones, who studies the Middle East more primarily and really, really great scholar, had basically done some analysis of hashtags relating to the Ukraine invasion. And he was like, okay, there's this hashtag, I stand with Putin, and another one called I stand with Russia. But here's the thing, it looks like a lot of people are supporting Vladimir Putin and this invasion because these hashtags were trending, at least in like the US. But when he dug into them, he was, no, actually, there's a lot of suspicious accounts that are pushing this. And Twitter is missing quite a few of them, but it's like hammering down quite a lot. Well, basically, they were burning through someone, we're not going to make an attribution here, but someone or something was burning through all of these accounts trying to astroturf, to provide this like false idea, this false sense that like that the war was justified and that there's a lot of people who are on the side of Putin. I'm not here to make this political, but just to give this a some background. And again, this is a kind of typical use case for this toolkit where I just collected data with the Putin hashtag. And again, I want to see which accounts had retweeted the same stuff within 1 second of each other at least 10 times. So, I'm kind of doing bot hunting in a way. And lo and behold, the accounts that are the red ones are the ones that Twitter had suspended. And then there was like a whole bunch of other ones that they'd missed. So why am I telling you all this? Basically, this builds on kind of like a new turn in computational social science research using network analysis. You can build networks to study online social media. You can retweet networks where like, if I retweet Bogdan, for example, there's like a link between me and you. They're a dime a dozen. They're very useful. They're kind of like the Hyundai of like network analysis for social media. Very useful. But what these kinds of networks tap into is a totally different paradigm. So it's not like me retweeting Bogdan, for example, but both of us having retweeted the same tweet elsewhere at the same time. And it's not only limited to that. There's other forms of behavior as well. So we might, for example, well, I don't want to, I'll pick someone else, Rio, for example. We decide, hey, we want to really show support for like this workshop. So what we do is we have like an Excel spreadsheet with a bunch of like tweets, and we're like, we're just going to copy and paste these like and send them out like 10 per hour, and we'll pay each other $1 per tweet. So it can pick up on this kind of like co-tweeting behavior, sending the same message over and over again. And more or less, this is the entry point for today. So what I'm going to be doing is trying to take you through a full workflow for how to fit these kinds of networks. I'm going to be using real data. Actually, I had to, another one, from an ethics perspective, I had to confer with my colleague, could I actually kind of share an I Stand with Putin data set with everyone for the purposes of this workshop? Real data, kind of a murky area of ethics, but he says, I think it's useful. So I'm going to be sharing you this data set. We're going to be downloading and using the data set that I used to do this analysis. So it's kind of, the stakes are real, I guess. What we're looking at is real. But please delete the data set after the workshop if you don't mind. So with this background in mind, what we'll do is I'll kind of try to step through this notebook bit by bit, and hopefully everything works. I was very fortunate that Rio was kind of encouraging me to put everything online using Google Colab. So it's, I've been kind of beavering away trying to make this work as seamlessly as possible. But if something goes wrong, this is kind of the Wild West of computational methods. So if you've got this open on your screen at the moment, the way that this basically works is that we've got these like boxes, and I know this is like a lot of people will be really familiar with this, but for those who aren't, I'm going to kind of run it through step by step. Some of the boxes have text in them, which explain what we're doing, and the other boxes contain code. And it basically runs like this. We're going to be clicking the play button, which runs a cell, and we'll go, cell by cell basically, and work through this, work through this notebook. So the first thing that we're going to do, I'm just going to jump straight in here. So we're going to be going from like directly into the weeds here. If you get stuck, please let Rio or me know, basically. So we'll try and make sure that no person gets left behind. But yeah, we're going to be jumping like right into it. So if you've got this open, you click play on the first cell, and you'll see that it's installing 4 modules that we need for this workshop. One is, of course, the Coordination Network Toolkit, Network X, which is a network analysis module, Pandas, which is like just a standard for handling data structures, and a really cool module called PyVis, which will let us visualize the networks in a kind of nice way. And then, this code essentially imports it, so it's ready to go. You'll see there's a bunch of output here. Don't worry about that. It's just telling us, whether or not everything's fine. And so what we're going to focus on for this workshop is analyzing 2 data sets or 2 case studies. So the first one is tweets containing this hashtag, 2 months worth of tweets. 2 months worth of tweets. And I have actually uploaded that data set to my Google Drive and used a little bit of kind of Python magic to make it possible to download the data into the notebook. So just slow me down if you have any questions, because sometimes there's kind of a lot going on, I guess, in the workshop, and I really hope we can get through everything in 2 hours, basically. So yeah, we're using Python. This is the Python programming language. Some people like R, some people like Python, some people like other things. I use them both. I don't know why, just depending on like the feeling of the day, I just wake up and start working on one or the other. But they both have advantages, both have disadvantages. So this is all Python code. But what this is kind of like a little trick where I don't want to explain too much, but for those of you who want to follow along exactly what's going on here, I'm going to anyway. This is the ID of the I Stand with Putin dataset on my Google Drive. And it's just a little trick. It's really fancy, well, at least in my opinion. I'm easily impressed. But this line of code here, it downloads this file and it will sort of store it in temporary files, which you can see. So if you look on the left-hand side, you'll see there's a bunch of things you could look at. And one of them is this files icon. And we're going to have 2 files for this workshop that we're going to use as input, 2 data sets. And what we're going to end up with is a whole bunch of files in there as well. And we'll kind of explain them as we go along. But running this cell will download 2 files, and see if I can locate them. It will download the I Stand with Putin hashtag tweets. It's a JSON file. So this is basically the data set that I got from Twitter using the Twitter API. So it's like, if you like, it's like raw data in the format that Twitter provides it to you in. The other data set, I'll talk about the other data set a bit later on. Oh, here it is. Yep. So tweets, Venezuela, June 2019, positive.json. This is, I'll talk about it later on, but this is a data set of verified, coordinated, inauthentic behavior originating from Venezuela, and one of hundreds of data sets that Twitter has provided as part of its sort of information transparency and information operations project. So the second part of this workshop, if we get time, will involve like analyzing verified, I guess, and attributed coordinated inauthentic behavior, if that's your thing. The first part will be more like live data, Twitter about the Ukraine invasion. So if you run this, you'll get the 2 data sets popping up in the files here. The next thing that we're going to do is, the way that the coordination toolkit works is that you basically get your data as a JSON file, but it can be other formats as well. And you run it through this big machine, which is the Coordination Network Toolkit. And what it does is it has to go through and examine the activity of all of the accounts in the network and map the relationships between them. And if you're a computer sciencey kind of person, this actually turns out to be not a straightforward problem, and it can take years for it to run if you don't write the code the right way. But what it does is it uses highly optimized routines in SQL databases. So TLDR is, it goes in, the data set goes in, it tries to map the type of relationships between this data and store it as a SQL database. So you're going to generate a database, some database.db, and that's kind of like your home base for generating these networks. You've taken your raw data, put it into a database, and then let 1,000 blossoms bloom, I think was the term that someone used the other day. You can generate all sorts of different networks. You can do whatever you like. But we need to get it into the database. Again, if you don't code, that's okay. But what the intuition behind this code is that we basically store a reference to the location of the data set. For Google Drive, for some reason, it stores everything in this content directory. So this reference is saying that in the content directory, there's this file, and we're going to refer to that using this variable JSON _ file name. So the question is there a difference between JSON and JSON-L? And as I understand, JSON-L is kind of like JSON, but it's new line delimited. So, okay, JSON is JavaScript object notation. And I mean, who's familiar with like CSV files? Like, yeah, I mean, I don't know, it's a kind of a stupid question, but CSV files are comma separated data files. So, it's like Tim, comma, age, won't say what it is, comma, location, blah, blah, blah. And that's how you store the data. Each row is a record in that CSV file. In JSON data, the records are not stored kind of sequentially as rows. They're stored in a different way. They're stored in kind of a nested format. So it's like nested boxes that you put your data into, and every JSON format can be kind of different. The records are stored as new lines, and that's JSON-L, JSON lines, I guess it's called. Yeah, but you can get really mixed up with this sort of stuff, and I don't want to make this like so technical that everyone like just goes, goes to sleep. But this is the kind of stuff to contend with when you're working with these kinds of data files, like JSON and JSON-L. They're really quite different, actually. Yeah, we store a reference to the database file here, and we call it DB file name for shorthand. And what this will do is it'll basically just create a database in the files. And these databases can get like super big, by the way. So it's fine for this data set, but they can just become like massive really quickly. Then what we're going to do would be running the coordination network toolkit, coordinate TK. And for those of you who aren't familiar with Python, basically we're calling functions. So we're asking for the toolkit to provide us with the functionality to pre-process JSON file inputs. And so, toolkit, the pre-process functions, and within that, this particular function, which contains methods to process our data. And we're saying this is the database we want to store it in, and this is the input file name. Again, it doesn't matter if you don't understand every detail of this, but what we'll get at the end of it is a database ready to go. So you can click play on that, and it will go. So what we're going to do to start with is we'll generate a co-tweet network. So this is a network where the nodes are Twitter accounts that are connected if they both tweeted the exact same tweet within some time window of each other, at least a minimum number of times. So what we're going to be doing is we're going to be, again, calling on functionality in the toolkit. We're going to be calling this function, compute co-tweet network, specifying the database where our data is contained, specifying a time window. So here we'll say 60, which is 60 seconds. And what this means is that accounts will end up in the network if they both tweeted the exact same text, like character for character, within a minute of each other, at least twice. So we're going to specify a minimum edge weight of 2. And this is actually, I don't know, on a practical level, this is actually kind of a strict setting for co-tweet behavior. Like the chances that you're going to be tweeting the exact same thing as someone else, within the same minute, at least twice is like, you know, it's kind of a strict kind of threshold. A lot of the time when I'm using generating code tweet networks, I just like specify a week. You know, I'm just interested, like if anyone in my data set tweeted the exact same thing as each other, you know, like, oh, I love, you know, Ukraine, and how great is Vladimir Putin? You know, the chances that two people will write that exact same tweet at all are kind of slim. So I tend to have quite a large limit, but we're going to set a small one, not least because I don't want the network to be too big. So it's kind of a practical choice. So you run this and it will kind of output a bit of a log about what it's doing. So it does some text normalization to the tweet text itself. Just make sure all of the bits and pieces are together, and then it'll, you know, run and tell you how far it is into it. I'm surprised how powerful these Google Colab like machines are. Like it just eats up this this data. So it's probably a bit faster than my laptop, to be honest. So don't use your laptop, I guess, unless you've got a great laptop. This is really, really quite fast. And what that will have done is it will have actually stored a code tweet network in the database itself. So now the database has not only the data, but it's got a network, a code tweet network that you've generated. That's all well and good. But I'm kind of old school, and I like to work with the networks sort of separately. So what we're going to do is we're going to output the network, the code tweet network, to a file. So again, it's the same routine. We're calling on methods and functionality in the toolkit, and in this case, the output GraphML file function. And we're specifying the database, the type of network that we want to output. We've just calculated the code tweet network, so it's ready to go. And then the file name that we want to use. And I've just specified, you know, I stand with Putin. It's a code tweet network, and the time threshold was 60 seconds. And what this will do is write a GraphML file to your local disk. Now, GraphML is like HTML for networks. So a GraphML file is kind of like a standard way to store network data on your computer. Gephi is the one I recommend, and I think we'll use that as well if we get a chance. So that was like, I want to do like the sort of more, not dry, more technical stuff first while we're still fresh, and then, yeah, it's a good question. We're going to get into Gephi land and analyze these networks. And honestly, like, I'm a computer scientist, and then sociologist and computer scientist, but Gephi is where I feel most comfortable. If I'm actually doing analysis of these networks, I want to do them interactively. So yeah, we'll jump into Gephi, and you can open GraphML files in that program. But for now, you know, this may not be the best way to do this, but I just want to kind of run through each step so that you kind of get a sense of how it works. Now that we've written this GraphML file, which contains our code tweet network to file, I'm going to actually import it back in as a distinct network object. So what we're doing is we're writing it to disk, and then we're going to reef it back in again using the network X, or NX for short, module. And what that means is that we'll have if you run this code, you'll have a network object. I call every network like G something, so G for graph. And in like network analysis, it's this weird thing where like some people call them networks, some people call them graphs. Mathematicians call them graphs because like graph theory is the mathematics that underpins network analysis. Normal people call them networks because they're networks. I don't even know why I'm telling you this, but graph network, it's the same thing. And then just to kind of sanity check what's going on here, we can run a few methods in network X just to sort of ask, well, how many accounts are in the network? How many nodes? So we run the number of nodes method, and it tells us that there's 290. How many edges? It's 285. So we know that there's 290 accounts that have co-tweeted with each other at least, well, 285 times in our data set. I spent like hours trying to find a combination of parameters that would give us networks of about this size. So I'm kind of like, this is not research. I'm trying to engineer networks that are not going to be hugely big to analyze. Now, normally you don't really visualize network data in Python, but I wanted to give it a crack at doing it just for the purposes of this workshop. And I figured out a way to do it, basically. And I think it's kind of cool, but it does require a little bit of extra coding. So this code here, what it does is it takes the username node attribute. So each node in the network has like information about it. It has like a username. It also has like information about what its most recent tweets were. So if you look at a node in Gephi, it'll say, oh, you know, its last 10 tweets were buy Bitcoin, I love Bitcoin, buy my Bitcoin, send me, you know, that kind of thing. And so you can kind of get a sense of like what the nodes are based on their node attributes. This is just like a stupid little hack that assigns a new node attribute. It sets a new node attribute on our network called title, and the title is just the username. And the reason I do this is when you run the next cell, which contains code to generate an interactive network visualization in the browser, if you zoom in here, you can use like your mouse wheel, I guess, you'll see that when you hover over the nodes, the username comes up. This is like totally a hack. It's just something that I just, you don't have to do this, but I find it kind of useful if you wanted to see what's going on. And like more or less, this is this is the network. So what we're looking at here is the co-tweet network, where these nodes, for whatever reason, have tweeted the exact same message as each other at least twice within a minute of each other. But we don't know why. At this point, we basically get to social science world, part of computational social science, where you can run network analysis on this, but it's not really going to get you that far. What you really want to know is, like, what's going on here? Who are these guys, right? And that's why, you know, this toolkit is kind of geared towards the study of coordinated inauthentic behavior, because the next part of it is really qualitative, and it's far more time consuming than generating the networks. And a typical workflow for me is to get this network, put it into Gephi. We'll do this in a second, and then, you know, start to do qualitative forensic analysis of these clusters. Now, going back to like the whole modus operandi of this toolkit, like it's unreasonably effective at finding clusters of accounts that are up to something. It could be the case that these clusters are just here to shield Bitcoin, and they're just jumping on the I stand with Putin bandwagon. Some of them, and I know in advance because I've looked at it, just tweeted the hashtag with nothing else. So they turn up in the co-tweet network because they both tweeted I stand with Putin within a minute of each other, and only that. So, like, again, it's a difficult problem to answer, like, what are they up to? And other ones have been suspended by Twitter already. But this is more or less the principle of this approach. So you can kind of devise different kinds of behavior, different forms of coordination that you're interested in, put your data set in, and it will return to you these clusters that you then have to analyze. Like that's what you do. And I mean, we can talk about it later on. I don't want to like stand here and like give a boring lecture about the theory that underpins this, but recent work around coordination network analysis has been published in Nature Science, and it shows that this approach is unreasonably effective because it taps into the production process, the production regime of how people run influence campaigns. If you're interested, it's called the principal agent problem, and these network analysis methods work because if you think of like a troll factory, for example, you know, take the Internet Research Agency that operated in St. Petersburg and still does actually, that had about 3,500 workers or agents, if you like, who sat at computers in a pretty nice, well, it's not actually that nice, but it was pretty good, you know, good resources. They had computers and they more or less tried to fool US voters and spread preferred narratives of the Kremlin in Russia. Why am I telling you this? The problem that these kinds of like troll farms, I don't know, troll farm is not a word I really like, but like these kind of like coordinated influence operations, they have managers and like principals, if you like, who have to sort of say to everyone, okay, everyone listen up. Have you got your morning coffee? All right, good. So today what we want to do is we want to create some new profiles and spread the message that that Joe Biden is too old to govern. For example, you know, we want you to kind of be ageist, and we want you to spread this idea. Now, that's all well and good because, you know, you say, okay, go and do your work. And the principals can sit back and do whatever it is that they do. And the 100, you know, trolls that they're responsible for will do their job. The problem is, you know, the trolls don't really care a lot of the time about what they're actually doing. They just want to get, you know, paid for their work. So they'll take shortcuts. You know, so for example, they'll do what like Rio and I would do if we wanted to like run an influence campaign about how computational social science is. I literally just have a text file and I just copy and paste, you know, and it's like super fast and I get it all done in like 3 minutes and then I just like log off and I get paid $1, you know. And this is the principal agent problem essentially. Here I am going into like theoretical detail about this, but that's how these work because it would be better if these accounts spread out their activity, but they don't. Oftentimes these clusters turn out to be one person who controls like 20 different accounts and they just like spammed it all at once and then logged off or started playing video games or something. And that principal agent problem, which is a well-known kind of theoretical concept, especially in like psychology and economics, that's why we get these kinds of things. It's this asymmetric relationship between the principals and the agents, the ones who run the campaigns, and the ones who actually carry them out. I'm not going to say any more about that because I can already start to see, you know, the blinds closing over. So, but it's on a more practical level, you can do some fun stuff here. And one of the things you could do is choose a different layout algorithm. And so if I choose like Force Atlas 2, for example, it sort of brings the nodes in a bit more tightly. Hierarchical repulsion. You just play around with the different layouts to see what brings out the structure and what makes it easiest to do your analysis. And before we jump into doing some analysis in Gephi, again, this is not the nicest way to do it, but I wanted to kind of have an all-in-one script that you can refer to. Now, the question would be, you know, say, for example, if we were interested in one node, like this one, for example, Scary Ghost 40, you know, what did Scary Ghost 40 actually talk about? What were they up to? So what this code does is it's very basic. It basically goes through each node in the network and it prints out like the latest tweet that they sent. So it's stored as a node attribute in the network called message 0. And by default, then the coordination network toolkit stores the last 10 tweets for each node. So you don't have to like go to Twitter or to your data set to figure out what a given account was talking about. You can simply sort of refer to it in the network itself. And again, this is a really basic way of doing this, but I'm just going to search for Scary GH, and have a look at what Scary Ghost was talking about. So you can see here that they retweeted this account called Comsoy, and they said, whatever good stuff you're doing that's bringing results, however small, do more of it. Yeah, I really don't know how to interpret that, but this is in principle how you go about doing this analysis. What we can do is go to Twitter now. So I'm just going to copy Comsoy, go to Twitter, and yeah, this is kind of like your nitty-gritty of like forensic analysis of these networks. I'm going to type into the URL bar twitter.com/comsoy, and yeah, it's Appears to be a person who joined 12 years ago, Nili, from Nigeria. They have a website, Comsoy Hub. They don't have many followers. They like writing, and I'm just describing what I'm seeing. Okay, you know, it's and for whatever reason, that they're being retweeted by by this node in the middle here. This is what we can do basically. We now have the network, we can play with it. I don't know what's going on. Like, we are literally finding out new stuff that we don't know about information operations targeting the Ukraine war. So I don't know. And by the way, sometimes you see stuff that isn't very good or nice. So, you know, I forgot to make the disclaimer at the beginning, but yeah, this is it's real data. So if anything makes you uncomfortable, yeah, please don't feel like you need to analyze the data. The question that I would have burning in my mind would be, well, who are they, right? And so, like, let's have a look at Scary Ghost 40. Scary Ghost. Yeah, like scary, whatever. Yeah, like you said, appears to be, I think that's Hindi. And yeah, I don't really think that we want to go into too much detail of analyzing accounts, because I don't know what we're going to find here. But for some reason, this account is being, or all these accounts rather around it are, like you say, swarming to post the same content for some reason. So maybe Scary Ghost is literally posting the same thing. So like, for example, like, let's look at this one. Dipanshu Buja 16. So again, this is an insight into the world of like doing this forensic analysis. It's not pretty, but sorry, what was the name of that again? Can anyone remind me? It was, yep. So I'm going to just search for Dipan. Yeah. So there's this account. And they just tweeted, "I stand with Putin." So that's why they're turning up here. They're just like jumping on and expressing support by just spreading the hashtag. Now, from like a perspective of what actually went down and what like the CNET reporters, remember who wrote the article? Anyway, the CNN reporter, I can't remember their names. They were the ones that were like, someone is trying to boost the I stand with Putin hashtag into the trending list, and they're just throwing like a whole bunch of information operations material at it. They're burning through thousands and thousands of accounts just trying to get this thing into the global trending list. And I guess that's what, you know, that's what these accounts were doing. Like their sort of their sole purpose seems to be just to kind of like pile on and game the Twitter trending algorithm by getting this hashtag like amplified into it. You see it all the time. Like I've seen it in the Australian Twitter sphere, for example. So I did some work a few years ago looking at the Dan Lied People Died hashtag. So there was these like hashtag campaigns that were trying to like push the idea that Dan Andrews, the Victorian Premier, was responsible for killing people because of the way that he handled the hotel outbreaks and the Victorian outbreaks. And anyway, like I don't feel great about this work that I did, but I identified like one of the first like accounts that had tried to spread this hashtag, and like it did nothing for a whole bunch of time in between when it started posting about Victoria, but before that it was only posting in Hebrew. Yeah, well, K-pop is another one, but yeah, it was posting like about like the Israel-Palestine conflict, and it was only posting in Hebrew, and had no interest in Australian politics. And it had and I disclosed this to like Paul Barry from ABC Media Watch, that, you know, this account like woke up and suddenly one day decided that it wanted to start spreading this hashtag. And I said, please don't like, you know, don't give the account name out and things like that, because it could be a real person. Who knows? But yeah, anyway, it got suspended by Twitter, and it was a sleeper account, you know, as you say. Maybe that's the case with these. Like, you just don't know, and I don't know what's going on with these guys. But yeah, so that's the that's the question. You know, you just go through these networks and try to determine what's going on. Sometimes the accounts might be really old and they wake up. Sometimes they were created yesterday. Sometimes they're real people. Yeah, so I guess in principle, that's how you go about generating like a code tweet network. But there's all sorts of other networks that you can generate. And what I was thinking is we'll shift gears now away from coding world, and we'll look at a co-retweet or coordinated retweet network, basically similar to what I analyzed a couple of months ago. And we'll analyze it in Gephi. So you can download Gephi by clicking on this link. It's free software. It's a network analysis program that I use for like pretty much every paper that I do visualization. What we're going to do is we're going to analyze a coordinated retweet network in Gephi. So to do that, the code cell is basically the same as what we've been looking at so far. The difference here is that rather than computing a co-tweet network, we use the co-retweet parallel function. And again, we specify the database that we've saved. We use a time window of 60 seconds, and we use a minimum edge weight of 2. So it's kind of a standard approach, and we can talk about it once we get into Gephi a bit more. But what this will do is calculate the network, and then the next code will write it to file. So again, output GraphML function. This is our database. This is the type of network we want to output, and this is the file name of the file that we want to output. And so once we've run this, it will save it into the files, and you can see it's here. It's about 20 megabytes, but for some reason, in my experience, downloading it is slow for whatever reason. Takes about 3 minutes or something to download. But you can download it if you haven't already just by clicking on the little sort of dingly three dots button on the end. I don't know what the technical term for that is. I'm not a UX designer. And then download, and it'll save it to somewhere on your computer. And then we can more or less kind of like step away from coding world, and we're going to be stepping into Gephi. So I'm going to open up Gephi. On my machine, I just sort of do it this way. And when Gephi first starts up, all going well, you'll see a splash screen as it loads all of the modules, and you'll be presented with a welcome dialog box that gives you a few different kinds of options for things you can do. So for those of you who are new to Gephi, Gephi, again, it's the industry standard, more or less, for doing network analysis. If you see like networks in the biggest journals, visualizations of networks in the biggest journals across multiple fields, chances are they used Gephi, and there's a very good chance they also use the Force Atlas 2 layout algorithm. So we'll get into that a bit more in a second. What we're going to do is just open a graph file. So you can click on Open Graph File under New Project, and direct Gephi to wherever it is that you stored, saved that. So for me, it's in Downloads somewhere. Actually, what did I call it? Here it is. So yeah, I've actually saved it twice. But it's, yeah, we're selecting the I stand with Putin, co-retweet, 60 seconds, GraphML, and click Open. And this network is considerably bigger than the previous network, but hopefully everyone will be okay with this on their computer. I think it's big and not so big that it's going to become frustrating for everyone. And what you can see is that it gives you an import report. This is basically a sanity check. If something went wrong, chances are it'll say that there's 0 edges and 0 nodes in the network. And so it's basically, it's screwed up somewhere. But we know that this network is healthy, very healthy, actually. There's 10,000, nearly 10,500 almost nodes or Twitter accounts. and they coordinatedly retweeted over 70,000 times. So this is as like my senior research assistant, Dan likes to say, this is a unit. It's a big unit, this network. There's a few other things you can do with Gephi. I'm not going to get into the details here, but you can more or less leave these options as the default, and that's fine for what we're doing, and click OK. So you can see that Gephi is pulling in all the network data, and it just looks like a big square. It looks absolutely disgusting. So here's where we get into visualization town. So the objective of network visualization is almost always to lay out the network in a way that presents and reveals the structures. So network visualization is like 95% art and 5% science, I think. Probably even more art. But so what I'm showing you here, I think, is really kind of a standard setup for doing network visualization. Others might do it differently, but this is the basis of how I do it. So the first thing that we want to do is to get rid of this square hairball of nodes. So there's a number of different like dialog boxes that you can see around here in Gephi. I basically have like a three-step kind of approach. And the first is just to choose a layout algorithm. So you can see it might be in a different area of your screen, but you'll see somewhere that there's a layout pane and you can choose a layout algorithm. I'm actually going to go with the tried and true Force Atlas 2 algorithm. This is what everyone seems to use, and it works quite well. And I'm going to kind of share a few tricks as well. Now, if you just run the default, so we've selected Force Atlas 2 and you just click run, you'll see that the network starts to rearrange itself using, actually it's kind of a physics-based model. So it's based on like attraction and repulsion. Nodes that have stronger connections together and more connections will be attracted, and ones that are further apart will drift or repel each other, or even if they're not connected entirely, like this poor island here drifting away to the northeast, it's being repelled out of reality. So this is like a starting point, but it's still not good enough because you can see that there's all sorts of stuff going on. We got islands flying up everywhere. We've still got a hairball. So let's try and improve it. For coordination networks, I don't know why, but I soon learned that one of the easiest tricks to making them look good is to turn on stronger gravity for starters. So I'm just going to click this to show you what it does. It's a little box here you can click, and it's like walking around on like a super massive planet where it's just like gravity just like sucks you in completely. And you can see that it's creating a black hole in our network. So if you zoom in, you'll see that it's kind of like it's looking bad again. But what we do is we blow the network up using scaling. So I'm just going to pick a random value. I'm just going to pick 100. So we're going the factor of 50. We're going from 2 to 100. And you can see that it's starting to take shape. And most importantly for visualization, what I'm trying to get towards as I affordize this network, as I kind of use the affordances of Gephi to bring out the structure and reveal the structure of the network, is this kind of thing where you can clearly start to see that there's different clusters of activity, and they're the clusters that we're going to want to have a good look at. But let's go a couple of steps further. So we've come to this point. The next thing that I want to show you how to do is, it's a personal preference, but I just don't like the black and white layout. I like to go inverse of land. So I like to have a black background. You can click this little light bulb in the bottom left-hand corner to go to make it dark. Obviously, you can't see anything because the nodes are black as well. So in the appearance pane in the top left, you've got a number of different things you could do. You can change the appearances of the nodes. You can change the appearances of the edges. But we're going to change the color. So it's this little dingle here. Click on set color, and I'm just holding it down, and I'm just going to click, choose white. I just find it a little easier to visualize these networks. Force Atlas 2 will just probably keep running forever, and it's not really cycling through time. It's trying to adjust the nodes in a way that's optimal according to its own rules of what optimal is. But for those of you who do maths or statistics or anything in the crowd, it gets stuck kind of in a local minima, essentially. So it's kind of bouncing between alternates that probably would never stop. It doesn't converge, this algorithm, or at least in my experience. I'll have to check the details. So it'll just keep running forever. And you can click stop if it is annoying you, and get it there. But I'm gonna keep it running as I go. So this is kind of like a starting point, like a very basic starting point. But again, the objective is to sort of like remove nodes from the network that are not interesting, because we want to focus on ones that are actually likely to be inauthentic, or at least are doing something suspicious or worthy of our analysis. So what I'm going to do is, I'm just kind of jumping around my workflow here, but it's the logic of it is that we get the network visualized to a basic standard, and this is not a bad starting template. Force Atlas 2 works really well. Strong gravity, blow it up using scaling, and it almost always seems to work well. But what I want to do is focus on now filtering the network a little bit to remove accounts that aren't really coordinating very much. We want to focus on the ones that are really like have a repeated pattern of amplifying the same tweets together. So in the filters dialog box, you can see there's a number of different kind of functions that you can run, and we're going to look at topology here. So if you click the topology button, it'll provide you with a bunch of different topological transformations that you could make. And what we're going to do is we're going to drag degree range. So I've literally clicked on that, and I'm dragging it onto the queries here. And what we're going to do is we're going to raise the bar for who gets to be included in this network. So currently, the degree of a node is measured by the total number of incoming and outgoing edges or links to it. So at the moment, the degree range is 1. It should actually be 2. Let's not get into the details there, but Gephi thinks the degree range is 1. And what we want to do is we're going to increase that to 10. And so the intuition is that what we want to do is only include accounts that have coordinately retweeted at least 10 times with another account. So if a node has a degree of 10 or greater, it means that it has retweeted the same tweet as another account within 60 seconds at least 10 times by the construction of this network. So that's kind of like quite a high bar. It might be the case that it would definitely be the case that if you only had a minimum edge weight of 1, a degree of 1, you're going to have stragglers in here, like hundreds and hundreds of accounts who just happened to retweet Elon Musk or happened to retweet, I don't know, a Russian embassy or something like that. So I'm going to click on this. Gephi still has a bit of crying pain. It's not the most user-friendly. So you kind of have to click on 1, and then I'm just literally typing in 10 and then pressing enter. And it doesn't do anything. So now the degree range is 10 to 286, meaning that nodes must have a minimum degree of 10, and the node with the most number of coordinated retweets is a node that's done it 286 times. And then click filter. So I'm going to click this button here. We've changed that from 1 to 10, and then click filter. And you'll see that like this filters the network down, so we're kind of zeroing in on accounts that are coordinating a lot more. But let's go even more. I'm going to, just to show you kind of how it works, I'm going to bump that up from 10 to 20. Hell, let's go up to 30. I mean, why not? All right. So now what we've got is a much smaller network But we can see that there's clearly 3 clusters that we're identified. And the accounts in these clusters have all co-retweeted at least 30 times with another account. So they're up to something. And I can tell you straight away that what we're doing here is we're more or less reproducing the analysis that that I published online and that got kind of written up like by journalists and things like that. And we can actually click stop. Like at this point, you can kind of finally say, okay, that's good enough for me. The next thing that I'm going to do, just for kind of completionist's sake, is let's make the network a little nicer in terms of the color. So there's a lot we can do, and this is just like the bare basics. This is like ordering like, you know, a sandwich with cheese and tomato. It's like, it's going to fill you up, but it's like not going to win you any awards, and probably you couldn't publish it or start a restaurant. But yeah, you've got your filters here, and then you've got another pane next to it called statistics. So statistics is basically just different kinds of algorithms and that you can run on your network to learn things about it, to calculate things of interest about the network. And there was a question before about what's new in Gephi. Well, previously there was only one community detection algorithm. So basically community detection is an approach to getting the computer to tell you what are the communities contained within a network. So if it was like a friendship network, it might be like, hey, there's like, you know, this community of people who like soccer, and so they're all friends because they're all on the same team, blah, blah, blah. This is a kind of mathematical way to do that. But now there's 2, statistical inference, which technically is a better thing to do, but I find the result aren't as good, whatever. I don't know. I haven't had a lot of luck with statistical inference, but that's a better approach. What we're going to run is just the stock standard modularity algorithm. So you can just click run. It'll bring you a dialog box up here. We can get into the nitty-gritty if you like, but changing this number will basically try and tell the algorithm to find you more or less communities. So maybe you want to find like, you know, 3 communities, like here, you know, we can clearly see there's 3. But if you wanted to sort of like find communities hidden within this one, then you'd change that number. Anyway, we'll click OK, and it will run. It'll take a little bit of time and provide you a modularity report. So what's of interest to us here is that the measure of modularity, so the measure of sort of patterns of connectedness in the data, if you like, is a 0.25 almost out of 0 to 1. The higher it is, the more modular, I guess, that the network is. And how many communities were there? So it's detected actually the 22 communities in this. And this is basically the frequency distribution of the community. So we see that like the first community 0, class 0, has, you know, well over 140 accounts in it. And most of the communities tend to have, you know, around 60 nodes in them. And there's a few communities that have basically got barely any. That's okay. So what we can do then is we'll color the nodes according to the community that they belong to. Yeah, so it's a stochastic algorithm. So every time you run it, you'll get a slightly different result, but the results won't be wildly different. They'll fall within a kind of range, if you like, of each other, but they'll be roughly similar to each other. It's just that there's random number generation that's going on when it does the community detection. So it's not a deterministic algorithm. I'm just going to say I don't use the modularity algorithm for actual research, like papers, because it's really handy for working in Gephi, and you probably could use it. But what I tend to do is I have my GraphML file in Python or R. It doesn't matter. Actually, R, in my opinion, is better for network analysis. So I'm just going to put that out there. There's more packages, and they're built by network scientists. I run the algorithm on the network directly in like a programming language, and then I like the community clusters as node attributes. And the reason I do that is because I want to publish the code so that other people can reproduce it and not have these kinds of problems and not be stuck in Gephi land. So it's kind of like, yeah, so it's a good algorithm, but like you said, you know, it's a Louvain method. And if you read that paper, I think from memory, don't quote me, this might be misinformation, but I think Louvain is actually for directed unweighted networks. So if you want to get technical, I don't even think that you technically should be running this community detection algorithm on this network, because the assumptions of the algorithm itself, the assumptions of the network, assume that you don't have weighted edges, and obviously weight matters a lot when you're looking at this. So for example, in the R language, you can use a command called set.seed, and in brackets you put a number in. I tend to use 42 for geek purposes. But yeah, you run a command, and then it sets a seed number for the random number generator, and then whatever is run after that is deterministic because it uses that seed number to generate the random numbers. And you can do the same in Python, but generally the seed number is set as a parameter for the model that you run. So I think I can't even remember the network community detection algorithm I use the most at the moment, but yeah, you set the seed number when you run it, and then that way, yeah, other people will get exactly the same results. The same applies to topic models. Like, I'll never run a topic model ever, not even if I'm just screwing around without a seed number, because sometimes you get a great topic, set of topics, and then it's like, I can't get them back again. And yeah, so yeah, the whole point of this exercise was to go into the appearance pane, nodes, color. I've got this little palette open, clicking partition here, the partition one, and then we choose modularity class as the color. And actually, this kind of looks crappy. I think this isn't going to work very well, but I'm just going to click palette and choose the default one. I'm actually red-green colorblind, so it's just really difficult for me to visualize networks. I just use default colors all the time. So again, I've clicked palette, just selected that one, and then click apply. And that's, yeah, exactly. Yeah, so like, yeah, so that's exactly right. You could get a different result if I go back here and run the modularity again, and I make the resolution 10 rather than 1. I'm just guessing here, but I just run it again using that. Yeah, now I've got 9 communities rather than like 21 or whatever it was before. And when I kind of go back into partition, so I'm just going to try this again. Yeah, so that's when we get a resolution that differentiates the 3 main clusters. And again, this is why it's like 95% art, because like, yeah, I'm not going to set a research design and say, I'm going to do this and that, because clearly I'm going to be sort of telling the story as it goes. And so, yeah, I mean, that is basically how I go about visualizing networks in a really basic way and getting the kinds of information that I need to do the analysis. So from a strictly sort of scientific point of view, if you are doing an analysis for a paper, what I'd suggest is that, or what I do, I guess, is I get the data in here and I analyze these clusters. I give them labels, the clusters labels. I try to get inside. I try to track the accounts as closely as I can. I may even do an additional data collection. So now I've got these 3 clusters. I might actually save that information and go and collect every bit of data I can about these accounts before Twitter suspends them. Yeah, there's not, but actually you can change the names. So like you can change 0 to whatever that cluster. And that's a good point. So this one here, I actually know what 0 is. And this is where we kind of get into the really fun sort of the more social science aspect of it, I guess. I zoom in here and you use this little this is how I do it anyway. Use this little edit node attribute button here. And, I just basically zoom into the network. There's other things you can do. You can resize the nodes. You can do all sorts of stuff, but we'll just keep it like this. I'm going to pick someone who's right in the smack bang in the center of this big cluster and just click on them. And then it'll having clicked on it, it'll bring up properties. And these properties are properties relating to the position and the aesthetics of the node within the visualization, and also attributes like information, node attributes about that node. And you can see here, I'm not going to drag this window across because it actually kind of screws the layout out, and I don't want to rock the boat. We're going smoothly so far. But you'll see that, you know, Plurbus Tech is the name of this account. So first thing I'm going to do is just copy and paste that into Twitter. I'm not actually going to visit the Ministry of Foreign Affairs, and I just look at it so much that it's in my history. Get rid of that and go to Plurbus Tech. So again, I'm just pasting in that name, and I can almost guarantee that it's suspended. So again, I think Twitter is more or less suspended like every single account. Whoops, that was in this cluster, but they didn't at first, and I called them out on it, and they didn't like it actually. And yeah, I don't know. This method was able to kind of say to Twitter, well, you've done a pretty good job, but half of these are still active, and you need to suspend the other half of this cluster. So yeah, that's a good question. So the question is, which of these should we use? Which of these like centrality algorithms should we use? Yeah. Well, let's use one, I guess. Like it's a really good question. So we've got these three clusters, and I kind of know what they are. So this cluster is actually like an influence campaign company that was actually advertising its services on Twitter until, you know, researchers like Mark Owen Jones and myself and others like were creating bad PR for them. Yeah, so if you go back and look at the tweet thread that I posted in the notebook, I think I talk about it there, and they literally saying, we will boost your hashtag into the trending list. And you go and look at the accounts and they're mostly focused on like the Middle East, like different countries in that region. But for some reason they got paid to boost this hashtag into, and it worked. So that's those guys. These ones are just like a spam company, and they're not really that interesting. It's like it's like a spam bot network. This one, the jury's still out on this one. It's a lot of Indian accounts. So whether it's like mobilized diaspora in, I think more like southern India, most of the time they're talking about like how bad, you know, I don't want to get into the politics, but yeah, the issues around race in India. But some of the time they're tweeting support for Putin, and that's a really complex thing. So we don't know whether or not they're authentic or not. They could be, they might not be. Maybe, yeah, it's hard to know. But you know, you could probably say that there's a chance that's happening, or that they're being co-opted. You know, like Olga was saying before, that there's like maybe 20 or 30 accounts that are going into these communities, and they're saying, you don't like, you know, Islamic people moving into, you know, the Hindu nation. Maybe, you know, we should support an alliance with Russia. You know that I'm just paraphrasing what I'm seeing them talk about. And then other people who are genuine are like, yeah, whatever, I'll give you a follow. And then yeah. So like heavy coordination is like high density. Everyone is connected to everyone else. Almost like a complete subnetwork, if you like graph theory, and very, very high edge weights. Yeah, like hairballs that just like, if you go into, this is the last part, but let's go into it anyway. If you go into the preview panel here, there's so much, we could do like a whole day on Gephi easily. But if you click on preview, change the preset to black background, otherwise it'll look nasty. And I guess we can just click refresh. Like, yeah, you can kind of see, to your point, that there's black space in between some of these accounts because they're not as coordinated. But this one, if you zoom in, it's like a little bit slow, so just bear with me. Like it's more or less like just painted, and the edge weights of these are so thick, like, you know, like they're like highways of like links between them, and it's just a hairball. and I mean, you know, that's how you find coordinated inauthentic behavior, I guess. I guess to deliver on the mandate of the workshop. But you find so much more. So you generate networks, but you can equally use this to study online activism, collectivism, participatory culture around like fan networks and things like that, who are all talking about a TV show on Friday night, or whatever night it lands on. So they really can do a lot, and I'm still not clear on what exactly it is that these networks capture. And I'm not even sure that coordination is the best conceptual lens by which to analyze these networks. It's one possibility. I've got a whole list of references, if you're interested in this method, that you can look at that do construe this as coordination. Others talk about synchronicity, you know, so there's like synchronized action is another term that's been used. But really, I think like the jury's out. It's like a new sort of subfield, I guess. And that's what you can do. So what we've got 15 minutes left, and like it'd be nice to do some, you know, I don't know if anyone's got questions, or I can just run through anything, you know, that we want to look at. Someone did have a question about, you know, what you can do using these network overview statistics that they're called. I'll just make it really, really simple. So if you want to measure like a rough measure of like power or influence in a network, like how influential a node is in a network, a rough parallel to that is the notion of centrality measures. So in social network analysis, a node centrality measures are various different ways to calculate how central a node is in a network. But the sort of conceptual or sort of sociological parallel to that is, well, how it's questions of power. You know, how much influence does a node have in a network? And probably like, you know, like the PageRank algorithm is probably a good example to run, because the PageRank algorithm was made famous by the two Google guys, Larry Page and Sergey Brin, and they developed this algorithm that calculates influence in of websites based on who links to those websites and who links to the websites that link to those websites recursively through the whole network. And it blew information systems out of the water. It was a revolution. Like, it was just an amazing algorithm. We went from like directories full of like places where you can look at cool pictures or great pictures of dogs and cats curated by experts, through to an algorithm that was unreasonably effective at like just somehow managing to find you the website that had the best dogs on it. So the PageRank algorithm is fantastic. And you can apply this to networks to tell you which nodes have the most influence in the network, because they are linked to by other nodes who themselves have influence. And so it's this kind of recursive sort of like nested measure of power or influence in the network. And we can, I'm actually going to run the SICSS-2 algorithm again. So you can see they're starting to jiggle around. So I'm kind of like, let's start the engine back up again. Run PageRank like this, and we'll just use the default settings here. And we will use edge weight as well. There's a chance that the results are going to be terrible and that like 5 nodes will have all of the PageRank and the rest of them won't, but let's see. So we can close this. It just basically this tells us like the distribution of PageRank. So PageRank is basically this. Imagine that we have a pie and like a pizza, sorry, and everyone gets a slice of the pizza based on how important they are. Well, the pizza is like one pizza, and so you divide that one by however number of participants there are. This is, I'm sorry, I don't know, like everyone's coming from different areas, but basically everyone gets a share of this PageRank unit of 1. So yeah, the more PageRank you have out of that share, the more influential you are. And now you can go back to appearance, click on the size icon, click on ranking. We're going to rank the nodes, and you can see that there's already a number of ways that you could rank them, but now we've got PageRank available as well. And yeah, what we might do is like, I'm just going to set a minimum size of 5 and a maximum size of, say, 50. So one order of magnitude should be okay, I guess, and click apply. Okay, I lied. You know, this is art. Let's go with 400. Sorry, minimum size 5, maximum size 400. Okay, we've gone too far. All right, you can see you can see exactly. This is hey, this is the secrets of network analysis. Let's go with 200. All right, that's a bit better. It still looks crappy. So what I do is, now that we've sized the nodes, I'm going to click this little toggle here, again in the layout. With the algorithm still running, I'm going to click prevent overlap, and you'll see them drift apart like this. It takes a long time to say anything in old Entish, but yeah, so they're going to keep going. I'm going to scale it up to, say, 200. I'm going to turn the tolerance up a bit to like 10. So basically it kind of, it'll make it go faster, but the nodes will sort of swing around a lot more. You know, and that's, you know, that's looking a bit better. And yeah, then suddenly you realize there's like this other little one at the bottom. Ta-da! So yeah, one last little trick, I guess, is I'm going to click stop. So I'm going to lock them in place. And then all I do is I reduce the max size. Again, make sure that you've stopped the algorithm. Reduce the max size to, say, 80, from 200 to 80. And what that does is it's sort of like, it keeps the spacing nice, but it spaces them out a bit. And when you go to preview, you'll see that we'll refresh it and reset the zoom. And I might turn the labels up, actually. Yeah, it does actually sort of reveal the structure a lot more when you do it this way. So you can see, for example, like there's nodes in this network of like apparently Indian accounts, and you can see that there's like pairs of them that are sort of like really heavily connected together. These guys, those two, and so again, you just want to find the structure to do the analysis. And the page rank, so you can see here, like if I click on this node, for example, this node called Himunch with a bunch of numbers after it has a page rank of 0.003. So, you know, it has a pretty substantial chunk of page rank, all things considered. And if we go and have a look at this account, this influential, powerful account, according to PageRank, it's actually still active. Yeah, so you're back in social science land. Yeah. So I guess for everyone online, the tip for sharing these network files is to export them as an SVG. And I haven't done that, but you could do it, play around with that. Yeah, so I guess we've got like 8 minutes before we were going to run till 12:30, but I think we're going to kind of finish up about midday. I just want to at least show you the rest of the code in that Colab notebook. Like this one is definitely an information operation, and it's a commercial offering. Both the inauthentic accounts that were carrying out the operation have been suspended by Twitter, and also the company, which was just advertising its services on Twitter as well. And there are actually a lot of them, so it's pretty rampant, despite what Twitter says. These guys were like, if you click on them, you can see like that they're just like a spam network that was trying to push like laptop technologies, AirPods and iPhones, getting people to like buy stuff, and they take a cut of it. Really like low level spam, classic stuff. Yeah, and then this one is This one's more complicated. That would be the subject of a pretty substantial paper, because the question is, these Indian accounts that are tweeting about Russia and are have a very strong narrative alignment to the preferred narratives coming out of the Kremlin, both the narrative themselves and the timing of those narratives, suggests that they are either sort of like a mobilized diaspora, you know, who find political affiliation with the Russian invasion, and or are pushing pro-BJP, Narendra Modi like narratives, and or are just like you know, Indian citizens on Twitter expressing themselves in a legitimate way. And I don't know the answer to that question. You do see that if you look at the tweets that they sent, they talk about the UN, they talk about NATO, they talk about they make statements that support the narrative that that the US has hegemony over the world, and that NATO is subjugated by the US, and that we need to abolish NATO. So yeah, and the UN. So they're kind of trying to steer towards disassembling alliances of liberal democracies, and you know, it's classic stuff. And we're not here to talk about political science and sociology. We're here to talk about methods. So, but yeah, you're right. Like, and this is the thing I've learned about studying disinformation. Like, maybe that's why I always feel overwhelmed, because whenever I'm studying like a new country or a new context or a new region, I feel like I have to understand like the history, and sometimes like the entire modern history of an area, in order to like make some kind of like valid analysis of clusters like this. You can't just go in and say they're bots, you know, and yeah. Anyway, I won't go on about this, but it's hard to do, and there's a lot of context required. We've got 2 minutes, so you know, I'm going to give it a crack, because I'm really excited about this one last little thing, little goodie for anyone who's interested. If you scroll down past the if you scroll down past the where we got to here, you'll see that I've actually included some included like a whole section that runs coordination network analysis on attributed information operations that Twitter themselves took down. So whilst in the first case study that we looked at live data, and we make a qualitative and or sort of mixed methods determination about what's going on in these networks. According to Twitter, at least, and the agencies that they are working with, these are state-backed information operations. Now, I picked Venezuela because it's just small enough that it would be nice to put into this notebook, because a lot of these data sets are huge, like they're multiple gigabytes worth of data, and we didn't want to get into that. I'm not going to run it, but I'm just going to explain what this code does for anyone who's interested. If you want to do analysis of these kinds of operations, there's a new paper that came out, like a really awesome paper by Guo and Basuhi. It came out just a few weeks ago, or maybe a month ago, in the International Conference on Web and Social Media, and it's a longitudinal multimodal data set that provides, it's a data set paper that provides data sets of state attributed information operations. There are limitations to what you can get, because they can't share like all the data, but where did I put the data sets? If you scroll down to about somewhere in this paper, here it is. So there's a link that you can follow in this paper that takes you to a repository. And you can basically go through and download like state-backed operations from all sorts of different countries. So, you know, take your pick. It could be embassies, but yeah, like people use proxies. And there is like information operations that target Western audiences in English about particular issues. Like Rio and I have been doing some analysis of like the Uyghur Muslim issue in Xinjiang. And again, like I don't know, I'm not going to stand here and like, this is so complicated, but it's way more complex than you think. And even though Twitter's taking them down and putting them in there, doesn't necessarily they're inauthentic. So we can talk for a lot about what authenticity means, and that the person who wrote like a 6-volume book about that in the 1970s, early 1970s, Lionel Trilling, if you're interested, and I think that's still a debate. So it's even more complicated than this. Nevertheless, according to Twitter, these were taken down, and you can explore them for different reasons. But yeah, just really quickly, because I know we're sort of a bit over time, with the Coordination Network Toolkit, so let me just go back to the page really quickly. This is important because if you want to study platforms that aren't Twitter, you need to get the data in the right format, basically. So I wanted to make this toolkit not just a Twitter analysis toolkit, but actually, if you scroll down, like on the GitHub page or on the PyPy module page, you can see that like it supports Twitter in JSON format directly from the Twitter API, either version 1 or version 2. So, you know, just throw your data sets in, it's good to go. But it also accepts CSV files as input. And if you process your data into a format where the columns are exactly as specified on here, then it can construct like coordination networks from that too. So again, we're working on like WebOR research, and I've used it on Reddit data, for example, cross-platform analysis of Reddit, coordinated link sharing from Reddit to Twitter and things like that. And so that's where it opens up into a whole other world where you can do any platform that you like. So I'm not going to explain the code, but I'll just tell you what it does. What it does is it imports the files as you get them from that archive. They're in JSON format, and the data looks like this. They basically give you the tweet IDs, user IDs. A lot of it's hashed, so they don't actually give you away what their real information was. It's like they use kind of cryptographic hashes and things. And they don't give you the tweet text, but they do give you the hashtags. They do give you the URL. So it's a little bit piecemeal what you can and can't get. But anyway, what the code does is it takes what they give you and it converts it into the correct format. For the Coordination Network Toolkit, it does a little bit of like, kind of micro level processing to some of the columns, like the message or the tweet column and things like that, converting the timestamps, just the usual kind of thing to get them into the right format. And then just a little bit of extra code here as well. So, like there's one step in between where you need to convert the pandas data frame into an enumerable object. I'm boring myself telling you. Basically, this code will get it in the database for you, and then you can calculate your co-link networks and things like that. Coordinated link sharing, and I'm showing you how you can do it using the default network X settings, and then what it looks like with the nice kind of approach. And that code will let you import and process and generate coordination networks of Twitter's actual takedown data sets, basically. But it also gives you a blueprint for how you could get data from any platform. In short, not all of the types of coordination networks can be calculated because some of them are language dependent. So let me kind of zoom in here a little bit, I guess. Ignore co-post because there's that sort of a work in progress, but there's 5. Co-retweeting is fine. It's language independent, like it's basically resharing, any kind of resharing functionality. Co-tweeting is language dependent. So like, yeah, obviously if you've got like Russian and English, even if they say the same thing, they're different characters, and so they're not going to end up in the network. Co-similarity is like co-tweeting, but you're just a little bit more relaxed. You're like, all right, if it's sort of like mostly the similar text at some threshold. Again, couldn't do that one. And co-linking is just like when they share the same URL. So yes, you can do that. Co-replying is if you've just replied to the same user. So that's fine as well. So yeah, you can't you can't kind of compare languages, and not all languages are necessarily supported. So again, like Rio can talk about this at length, but he's done amazing work to make the Coordination Network Toolkit work for our Chinese characters. So yeah, now it works for that, and it involves so much. I'm not a natural language person, a text analysis person, but word segmentation, it's like many languages aren't just separated by white spaces, and the Network Coordination Network Toolkit does assume that because it's built for English. If you want to use a different length, you know, it's open source, but you can also make a request, and we'd be like super happy to try and implement it. So yeah, it's, you know, just run it, see what you get out of it. But yeah, and I'd be really keen to hear like non-English, non-Twitter about that kind of research. And I'm just, yeah, I guess like this has been a whirlwind tour, like just trying to cover as much ground as possible for like, you know, like, yeah, but that's basically it. If you've got any questions or, you know, you want to run anything, I'll be around, you know, for lunch for a bit. Then unfortunately I got to head back to Brisbane, but yeah, that's the Coordination Network Toolkit. So thank you.